Welcome back, everybody, to America on the Road. Jackie Red back with you. We have a terrific guest, really interesting guest, maybe a little afield from what we typically do on America on the Road, but very apropos to what we're doing here in Southern California, and certainly apropos to the industry. With us is Danny Shapiro. He is a Vice President of Automotive for Nvidia. Chip maker, basically, I guess, among other things.
We do a lot of things, not just chips. We started out that way, but you're right. It's a lot more we can get into that.
Describe your company a little bit, because many of our listeners are probably not familiar with you.
Well, many people probably know us as a gaming company. That's how we got started over 30 years ago. We made graphics processors so people could play video games, basically, on their PCs. From that, though, it expanded into professional graphics, so anybody doing 3D for their work. It could be visual effects artists at DreamWorks or Pixar, ILM, or car designers, right?
Yeah,
engineers using CAD systems, computer-aided design, to medical imaging. So it sort of grew. Then we started bringing our graphics products into the car. So we started to see more and more screens appearing, consumer electronics, iPhones, etc., tablets. The car was lagging, so Nvidia was an early partner to many automakers, bringing that technology into the vehicle, touch screens in a Tesla, and Audis, and BMWs, Hondas, Mercedes, right? So that business really grew. Our company really, though, is an accelerated computing company. And what that means is, how do we make computers go faster? So graphics is one aspect of that, but now it's all about artificial intelligence. So Nvidia is really pioneering work in AI, bringing that into the vehicle, for sensor processing, and what that means is the cameras or the radar or the LiDAR on the car generates a lot of information that needs to be processed to ensure that the car can drive safely. And so that's what we're doing with companies like Volvo.
Give me a little sense of your background, how you got to this. Are you kind of an electronics guy versus an automotive guy?
So my background is electrical engineering and computer science. So I was originally a programmer. I did a lot of work in computer graphics. And so I did some animation work, I did engineering work, some design, and was working at tech companies in Silicon Valley for quite some time. And joined Nvidia 15 years ago. And we soon after started an automotive group to really take the technology and bring it inside the vehicle. And so developing hardware and software, a lot of software to provide those graphical user interfaces, but now more importantly, safety.
I'd really love to talk about that. But let's take a step back a little bit, because really infotainment has become such an important part of every vehicle. It's something that, as a car reviewer, I'm talking about maybe before I'm talking about the powertrain. It's something that we all interact with multiple times when we're in the vehicle. It can be both a satisfier and a big dissatisfier, depending on how you look at it. So walk us through kind of the evolution that you've seen of graphics and computing power in vehicles.
Right, well, I think if you consider any kind of computer you've ever had, whether it's your laptop or a home PC or now your mobile phone, every year new ones come out and they have greater and greater performance.
Right.
And they start doing well, and then they start to slow down because the software gets more and more and more complex. And so there's really this insatiable demand for computing power because there's more data and more code. So what we've been doing is really trying to change the model of how automakers used to operate. And by that I mean, in the past you'd say, okay, 5 years from now, we're going to design a system that will do this. So let's figure out what's the cheapest chip we can put in there in 5 years to be able to keep our costs down. And so they start working on this, and 5 years from now, this thing comes out and it's already out of date.
Right.
And so instead,
and it can't be updated. And
of course, everything is all fixed function. You had maybe 100 little chips doing all different things in that car. So instead, our approach has been, and really Tesla was one of the first to pioneer this, is you put a very high performance computer inside the vehicle, and all those little things that used to exist are now software apps. And so whether it's the windshield wipers or the locks or the windows or other types of things, your navigation, the music, etc., it all runs on that central computer. And so that's really what we've been pioneering, bringing a high performance central computer to the car, which makes development a lot easier. It reduces the overall cost, it reduces the overall weight, reduces the overall energy consumption because you just have one computer instead of all these tiny.
And which is kind of, essentially what we're seeing in the EX90 that
Exactly.
I've test driven today. It kind of tell us how it expresses itself in the vehicle.
The Volvo core computer is going to handle all these kinds of functions, and that's based on our Nvidia drive. And if you're over at the landscape area, part of the exhibit, you'll see it. It's about maybe 10-inch square. It's like 2 inches tall. It's liquid cooled, so it's part of the whole battery cooling, because we need to make it automotive grade, right? If you leave your cell phone in the car on a hot day, it'll overheat and it won't work.
Bad things will happen.
We need to make sure that anything we do in the car can operate in the freezing cold of winter, in the hot summer in the desert. It has to be able to handle the shock and vibration in the car. So there's a whole new manufacturing process that we go through for these automotive products that are different than what you would put in your laptop or your PC. But that core computer then runs all different kinds of software. And the key thing now is that your car will get software updates just like your phone. So your car is going to get better and better and better over time as new software developments come out.
Right. We've had some issues with that in the past. I think most of those issues are over, right? But I think there's been some frustration with people where the update didn't take or whatever, and then they're left in the lurch.
I think that's been a big challenge for the auto industry, right? The tech industry has been doing this a long time, right? We're computer companies. We're not auto companies, right? We don't have the same expertise and the ability to build vehicles like a Volvo does. But at the same time, they're going up a learning curve in terms of producing software that's robust and even managing that over-the-air upgrade. I know one of my early cars, supposedly it was software updatable. I had to drive it to the dealer so they could install new software there instead of getting it over the air. But you're right, I think it's gotten a lot better in general.
And get even more specific about the advantages of having one central source of computing power within the vehicle rather than a number of them around the vehicle.
Well, I think from a development standpoint, if you talk to Volvo, they're going to appreciate the fact that it's much more streamlined, having that single integration as opposed to all these different parts from all these different vendors running all different types of software, and then it sort of becomes an accountability issue. If something needs to be fixed, well, whose bug is it in the system?
Right.
So that's one aspect. Updating it is much easier. Rather than trying to update all these separate little components, you update a single computer. Testing, a lot easier. You test that whole single thing. And so that's one of the things we, of course, do is a huge amount of testing. We use simulation. So we simulate cameras or radar or LiDAR and can test whether the system is able to detect the person walking across the street or read the signs or the lights or whatever it is that the software needs to be able to do.
Right. Do you deal with the human-machine interface, how the driver or even the passenger would interact with, say, an infotainment system or control system, or not? Is that beyond what you do?
Generally what we do is we do the core hardware. We do what's called the operating system. That's kind of the software that sits below the user interface, whether it's the graphics or the sensor processing. That's all algorithms that we develop, but also work very closely with automakers. But that top level of the application, the user interface, how big the buttons are, whether you swipe right or swipe left or whatever it may be.
How deep the menus are seems to be an issue too,
so that is really usually under the purview of the automaker. They have their own UX team and they'll develop that look and feel.
I just want to know who to blame.
Now, in some cases, right, if you have Google running in the car or you have CarPlay, again, that interface would be handled through Google or Apple. But again, that integration is going to be done by each car maker.
Right. Well, to a lot of people, Volvo equals safety and safety equals Volvo. And it strikes me that what you're doing is really important to Volvo taking that safety to the next level. Talk about that a little
Well, I think now there's a direct correlation between the amount of compute that you have in the car and the level of safety. Because what we're doing is we're taking cameras that are running at 30 frames a second, the standard video camera. We have to analyze all the pixels in every frame of video and determine, is there a person, in front of the car?
Right.
Is there another vehicle? Is there a bike? Is the light green or red? Where's the lane marking? So in 1/30th of a second, we have to analyze that video and understand it, and then make a decision. And we don't just have one camera. There might be 8 cameras around the car, so it's a massive.
And it has to coordinate. That has to be coordinated too.
Exactly.
It can't just be one.
That's
one
right.
off kind of stuff.
So there's a massive amount of computation that has to happen every single second, and that's just for the cameras. Then there's also radar data, and now in the EX90 you have LiDAR, which is a laser scanner. So think about all this information that has to be processed in a flash. And so you need a very powerful computer. So the Nvidia Drive computer that's in there is over 250 TOPS. So this is a new metric.
I don't even know
it
what that
stands
is.
for trillions of operations per second.
Oh,
So it is a huge amount of computation.
Right.
So much more than your standard laptop. And again, it's designed for the sensor processing using artificial intelligence to be able to understand the environment and make safe driving decisions, turn left, turn right, accelerate or brake.
Walk us through how artificial intelligence figures into this,
Sure.
because I guess maybe it's kind of new to me,
It's
certainly.
very new.
Yeah. So talk
I
about
mean, I think most people now are familiar with ChatGPT, right?
Yeah.
And so it's this amazing system. You can type something and it will respond as if it's a human. But it's not like it was programmed. It was trained by feeding it data, feeding it language. So it basically learned how to represent human language, and then the knowledge from the internet or wherever the source was that was used to train the model. So this is known as deep learning. So instead of writing code, a program to do something, saying if this happens, then do that.
Yes.
Instead, we use data to train it, and that way it can understand and react. So not just using text, we can use that with images. And so this is something we've trained system. Let's just take the example of a stop sign. Older systems use something called computer vision, which was you still had the camera, you'd still look at all the pixels in the frame, but they were run through a program that was looking for specific things. Oh, a red octagon, white letters, the letter S with curves, a square looking T. So it would then run that code and determine whether that was a stop sign
or not. Right.
It required a massive amount of code, and it was slow. And so instead, deep learning let us, instead of writing a program, using the data to create the program. And by that I mean we train the system by giving it tens of thousands, maybe hundreds of thousands of pictures of stop signs. We might take them from all different angles, in the morning, at noon, at night, in dark, sometimes in the bad weather, with a bush covering part of it. And so it learns how to recognize a stop sign based on all this data instead of somebody writing code.
Yeah, kind of like how we learn to recognize a
You're
stop sign,
exactly right.
Yeah.
You show somebody something, and a child may not recognize it the first time, but you show them enough of them, and from different angles, they learn to recognize it.
Yeah.
So they build that vocabulary.
Yeah, I mean, even before they can read, they can probably grasp what a stop sign is.
That's right.
Yeah.
So that's the kind of the core level what deep learning is, using data to train these vision systems, but you can train it on any kinds of data. You can train it on how to recognize weather patterns, for climate prediction. You can train it on DNA sequencing, for healthcare applications. You can train it on how molecules bond for drug discovery. So this is why artificial intelligence is really taking off, because it can be applied to every single industry.
Well, it seems like we're maybe just scratching the surface on what it can do for us. There is the holy grail of the totally autonomous car, the car that will drive itself, right? A couple of questions on that. One is, let's talk about AI and how that can help us get there. And then I want to talk about the amount of computing power that's necessary to get that to kind of work.
No, you're absolutely right. And so these driver assistance systems that are going in the car are fundamentally the same architecture as what's going into a robotaxi. Zoox is operating in San Francisco and the Bay Area, and they're developing these bidirectional robotaxis, no steering wheel, no pedals. They're using Nvidia technology inside because they have LiDAR sensors and radar cameras on all 4 corners of the vehicle, surround. And so they have redundancy built in, but there's no human backup. Right. So it has to be spot on. So there's a massive amount of compute that goes in. Many of our processors are being used. And again, there's redundant systems, so that if one were to go down, the vehicle still has a fail operational mode.
Yeah, pretty critical. What are we going to see in the next 5 years out of this? I mean, you're probably developing at least 5 years out, maybe
Absolutely.
farther
Yeah,
than
yeah.
that. Talk
So
about that.
it's super exciting. Again, we're seeing this first wave of now these, the industry is calling it a software-defined vehicle, right? So it's a centralized computer. It has a set of core functionality now, but each software update adds new features, new capabilities, greater safety, maybe a highway pilot. The next software update could be a city pilot, and just all kinds of other software for convenience. We're also seeing AI inside the cockpit, so more of a concierge, where not that you have to then talk to Siri out in the cloud or to Google in the cloud, but the AI assistant knows your vehicle, it knows you, and you can have a direct dialogue about the car inside the car, so that's all running locally. And then if you need to go get information about a location for navigation or the weather or the time for a movie, whatever, it's going to go out to the cloud.
Are you building in a huge amount of quote unquote extra computing power just based on the fact that these will be upgraded and probably require that?
Absolutely, yeah. So that's the whole core thing. Instead of that previous model, which was what's the minimum spec we can put in? It's out of date. Now it's kind of flipped, and it's like, what is the most we can put in the car today? What is the best performance? And now it's into hundreds, if not our next generation, 1,000 tops into the car. And when that car is released, it might not use it all, but it's designed so that it can be upgraded to have a long life ahead of it. Instead of, in the past, you bought the car and it was the best it was ever going to be the day you drove it off the lot.
Right.
Now it's at its most basic level the day you drive it home, and it will just get better and better and better over time.
What do you think is the most exciting thing we're going to see over the course of the next 5 to 10 years out of this area and out of automotive?
So I've been in a lot of self-driving vehicles. If you've never been in one, it is truly remarkable.
It is.
It is. And I think there's a lot of people who are scared of it, and I think it's natural to be scared of something you might not understand or you've never experienced. But I see them all the time in San Francisco, where I live, and people get out of them and they're like taking selfies with the car. I mean, they just had this magical.
And they're still alive. It's really
amazing.
amazing.
Still alive.
Yes.
I mean, the reality is they tend to be very boring rides, right? I mean, that's what you want. You want to get in the car, you can do whatever you want, you don't have to pay attention, the car drives you based on the app, where you want to go, you get out, and you're done. So it's really quite a transformational experience when you're in there and you realize that this provides mobility for people who might not otherwise have mobility. And it's going to reduce congestion, I believe. It's going to be more energy efficient. It's going to reduce the amount of parking lots. That's another big thing, right? You have cars that sit around so much. These kinds of things are going to really reduce the amount of.
How soon are we going to go beyond robo-taxi to personal transportation that is autonomous? Or is that not even a model we should be looking at?
I still think, different companies have different models, but I still think it's a possibility. I mean, the classic stat is that your personal car is only used 4% of the time, right? So in some cases, it might not make sense to invest that money into something that's not really utilized. So I think a lot of shared transport, but there's no reason why you can't see this kind of capability happening inside of personal vehicles. We're working with, I said, Volvo, we're working with Mercedes-Benz. The next generation Mercedes will be using Nvidia Drive as well, and so that's going to roll out throughout every flavor of Mercedes-Benz over time. Again, a centralized, high-performance computer, software updatable, to get higher and higher levels of automation as it's safe. We're not trying to rush anything out. We want to ensure that it's purely ready for market, and so we're doing, like I said, a lot of simulation and testing both in the data center, where it's very safe, and then we put it on the roads for testing with professional drivers, and then once it's ready and approved and certified, it goes out to the public.
That goes out to the public. What should I have asked you that I haven't asked you about this subject?
Well, I think the key thing is kind of what makes a car company successful in this new era. And so how are the winners and losers going to be chosen? And so it really comes down to the rate of innovation that they can bring this technology to market. That rate of innovation is really a function of the 3 computers that they're going to use to develop it: the training in the data center, the testing and validation and simulation, and the performance in the vehicle. So it's not just about that computer that goes in the car, but it's the whole engineering life cycle that the software development goes through. So again, these are software-defined cars. These car companies need to become software companies, most importantly, to be able to produce good software great user interfaces and achieve a high level of safety and be able to quickly iterate and bring new features to market.
Yeah, I mean, PCs and phones are turned over pretty quickly. Like if you have a 3-year-old phone, you get a really old phone.
That's right.
Typically, right? A lot of people keep their cars a lot longer than that. The typical lease is just 3 years, and a lot of people are keeping their, I think the average car on the road is 11, 12 years old.
That's right.
Walk me through how you develop stuff that far out and has that kind of length.
That is a really good question. I think you have to recognize new technology is always going to be better than the previous generation technology. It's a fact. It should be, of course.
Right.
And so what we've done is we've really tried to create a very long life cycle product. So even as we bring out our current generation, it's called Drive Orin. The next generation is Drive Thor, right? These are named after superheroes from the comics.
Yes.
Right?
Yeah.
The software is the same that runs on both, but as you bring out the new one, you're going to get greater capability. It's going to be able to process more sensors. It's going to process higher resolution sensors. So that's also going to be a function of that vehicle, right? The vehicle 5 years from now is going to have better cameras, better radar, better LiDAR. So those things kind of in lockstep. The capabilities are going to evolve over time, but the point is, the car companies that we work with develop one software stack, and they can continue to enhance that, and regardless of whether they're on Drive Orin or on Drive Thor, they can be using the same software base.
Got it. Well, Danny Shapiro, so much interesting stuff. It's just fascinating stuff. I wish we had a lot more time to talk about it, but thanks so much for sharing all this with us.
It's my pleasure. It's great to be with you.
We appreciate it. And stay with us, everybody. We'll be right back right here on America on the Road.